Good morning. This is Mr. Herman with your proof remediation pretest today. And so we've spent a couple weeks going over proofs. So we're now going to kind of do a remediation of going back and looking at our triangles and our figures to identify some of the properties that we have in to prove congruency. So on number one here, we are asked what triangle congruency theorem shows that the pair of triangles is congruent. Okay, so that's going to be our angle, side, 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 angle, side, or side, angle, side. Okay, those are our four triangle congruency theorems that we can use here. So number one, I'm going to take a look here. I got a pair of angles, okay, with M and S. They both got 2 marks. I've got a pair of angles with K and U. They both have 1 mark. And then I have this side here with 1 mark. And we're going to call these angle, side, triangle congruency. Okay, it's not going to be angle, side, angle because the side that is congruent is not between my 2 angles. Okay, so go ahead and try number 2 on your own. Now, number 2 is a little bit different because we don't have all the markings down for us. We've got a marking for AD and BC. We've got 2 markings for DC and AB. So we know we've got 2 pairs of congruent sides, but we also need to think about the reflexive property. It's our favorite property, okay? And that's going to give us a pair of sides congruent because DB is in the triangle above and the triangle below. So there is side, 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 triangle congruency. Now, let's go and come down to 3 and 4. And we are asked, what is the reason to justify the statement about the 2 triangles? So, if we take a look here, we have angle JKN is congruent to angle MKL. Now, if we think back to how we name our angles, that middle letter there, K in both of them, is going to be the vertex of our angle. So where the angle kind of happens. Okay, so JKN is going to be right here. Put 2 marks since I already have 1 mark on these angles over here. And then angle MKL has 2 marks on it now. And those 2 angles are congruent because we see that there's an X formed there. If you remember, X's make vertical angles. Okay, so go ahead and try number 4 on your own. Now 4 is a bit tricky because of the angles that we're looking at here. Okay, and how our triangles are set up. We've got 2 triangles in this diagram. Our first triangle is going to be triangle A, B, E. I'm going to go that one in blue. And then I'll go over my other one in green of C, D, B. Okay, so those 2 triangles right there. If I'm looking at angle ABE, that's this angle right here in the middle. If I'm looking for angle CBD, that's also this angle in the middle. So this angle is the same. Typically, we've only seen sides that are the same in both triangles. But in this case, we have an angle that is in both triangles. And we said that if we have a part of the triangle that's in both parts, that it's shared between the 2 triangles, that is the reflexive property. All right, let's move on to numbers 5 and 6 here. Now, 5 and 6, they give us a bit of extra freedom of what we want to choose. So we're asked what property or definition would be a reason in showing that the following triangles are congruent. Now, for both of these pairs of triangles in 5 and 6, there are multiple possibilities. Okay, so we'll start with 5. And there's actually going to be 2 possibilities that we can see here. So what we just talked about in number 4, we have something that's shared between our 2 triangles. This here in purple that I'm labeling AD, we have that, put a mark on there. Okay, AD congruent to AD, and that's the reflexive property. Okay, but not only do we have the reflexive property there, we also have some markings up here okay, that are going to say that we have an angle that's congruent here and an angle that's congruent here. Okay, so that would be angle BAD is congruent to angle CAD, and that is the definition of an angle bisector. Okay, because we created this line AD, created two congruent angles. It bisected, it cut angle BAC, our big angle, and cut that big angle in half. Okay, so go and try number 6. There are up to 3 different properties that we can show, or definitions. All right, so let's take a look at number 6 now. As I said before, there are 3 possible properties or definitions that we can identify in this pair of triangles. Okay, we're going to start with the simpler ones and work our way outward. So, like we saw in number 3, we have this X shape in the middle. Okay, so I've got these angles across from each other. Those are going to be vertical angles. So let's label them. Angle PQT is congruent to angle RQS. And we said that those are vertical angles. Oh, that's not a good angle. That's better. Okay, so there's a pair of vertical angles. Now we've got a pair of parallel lines on the outside. That's what these arrows tell us. And we have this transversal PR because it's crossing through both PT and SR, those 2 parallel lines. And so we've got these angles right here. Okay, now we're inside the parallel lines. This one's on the bottom of the transversal. This is on the top of the transversal. So those are alternate interior angles. So once again, let's make a congruency statement. So you have angle TPQ. Notice how where that angle is the middle letter. And then angle SRQ. Okay, so those are alternate interior angles. Okay, and there's one more here, and this is a little bit tricky. This is one of our definitions, that we've got a right angle and a right angle. Okay, so we know that angle T is congruent to angle S because of the definition of right angles, or all right angles are congruent. Okay, so go ahead and work on the notes on the back of this page in order to prepare for your pretest today.